Let's begin by simplifying these imaginary and complex numbers. So we're going to start with number 2. This is also on your worksheet that's linked in the next slide. So please make sure that you're following along. This is I to the 6th power. If you guys remember, it's question number 2, by the way. If you guys remember anything from your exponent rules or exponent laws from middle school or freshman year, whenever it was, I to the 6th power means that I'm doing I times I 6 times. Okay. 1, 2, 3, 4, 5, 6. Okay. Additionally, so this just looks like I times I times I times I times I times I, right? If I pair these up, that would be an I squared pair, right? Because I times I is I squared. So I've got 3 of these I squared pairs, all right? And if you know anything else about your exponent laws, when I add those 3 2's together, I'm going to get I to the 6th power. So this does work. I squared, remember, I'm just going to write this kind of over here. I squared, this is on the slide, I squared is equal to -1. So if I have I squared times I squared times I squared, I actually have -1 times -1 times -1. Cool? All right, -1 times -1 is 1. 1 times -1 gives me -1. So I to the 6th power equals -1. All right, and you're actually going to find that pretty much I to any even power is going to give you -1. All right, and you guys will figure that out as you're working through the worksheet later. All right, let's do another example. Example 5 is the square root of -8. So before we even start talking about prime factorization and stuff like that, I'm going to go ahead and separate the negative and the positive component from this. So the positive component is 8, or I'm going to make it 8, and then the negative component is going to be that -1. And remember, 8 times -1 is going to give me -8. Okay. So now that I have this, we're gonna talk about prime factorization. You've done this before, all right? So I'm not introducing anything new. This is kind of like a review stuff. And if this is new to you, that's okay too. So prime factorization is when I create a number through multiplication using only the prime numbers that it's composed of. So I'm gonna start with an easy prime number is 2, all right? How many times does 2 go into 8? 4. All right, I circled 2 because it's a prime number. 4 is not a prime number because actually 2 goes into 4 as well, 2 times. Now, 2 and 2 are both prime. So now that I have all my prime numbers here, I can rewrite 8 as 2 times 2 times 2. And just keep that square root of -1 there. What I'm going to do next is kind of the same thing I did with the eyes on the other page. I'm going to kind of pair things off into squares. So this is actually going to be the square root of 2 squared times 2 times that square root of -1 there. The square and the square root cancel, all right? So only this 1, 2 is going to come out. The other 2 that I'm multiplying by, that's going to stay inside of my lovely square root there. Okay, and I still have the square root of -1. Square root of -1 equals I. Conventionally, I'll show you in a second, okay? Conventionally, I mean, this is correct answer, but conventionally we would write that I in front of the square root, same number. Okay, it just looks nicer, you know? And in math, we like things to look nicer. That's why we have simplifying. All right, cool. Last question that I want to go over with you guys is going to be number 7. It's also on your worksheet. And we're going to split this up kind of because it's going to be a complex answer. all right, just like the one before. So we've got square root of 24 plus the square root of -4. First thing I'm going to do, I'm just going to make things positive so that I can, work with things better. So I'm going to make this component, this 4, positive, and when I multiply by that -1, that's how I get that -4. All right, so that's done. We're good there. Actually, 4 has a square root, and that square root is 2. So I'm just going to rewrite square root of 24 plus, so if the square root of 4 is 2, all right, so this is 2, the square root of -1 is I. So actually, we can go ahead and simplify that to 2I. We're not finished, even though it kind of looks nicer than it did before. We need to do the prime factorization of 24 in order to simplify the square root of 24, because 24 is not a perfect square. So again, an easy prime number that I always start with is 2. 2 goes into 24 12 times. Okay, and 12's not prime, so I'm not going to circle it. And actually, 2 goes into 12 as well 6 times. 6 is not prime because I can take 2, I can divide it by 2 3 times. Right? 3 is prime, so I'm going to rewrite the square root of 24 as the square root of 2 times 2 times 2 times 3, and I'm just going to carry down this 2i plus 2i there. Okay. I'm making pairs, right? Squares and square roots cancel, so I'm looking for a square pair. So I got 2 squared times 2 times 3 plus that 2i out here. Okay. The square and the square root cancel here just for this 2. So I can pull a 2 out onto the outside. Square root, I cannot pull the 2 and a 3 out. So I'm going to go ahead and multiply those so that I get 6. 2 times 3 is 6 plus 2i. This is simplified, okay? This is our answer. All right, if you have any questions, send me an email. There's also a link to a picture of my work on the next slide.